Wait, do not throw away that old Office PC. Welcome to today's explainer. If you're someone who loves maximizing efficiency and just, unlocking the hidden potential of older tech, you are absolutely in the right place. Today, we're walking through the complete transformation of an old, seemingly outdated HP ProDesk 490 G2 micro tower. We're going to take that basic Office PC and turn it into a high-performance, 24/7 home server.
Seriously? What's going on with that thing? So many of us have one of these generic, black corporate boxes just sitting in a closet, gathering dust, or worse, heading straight for the e-waste pile. But we really need to reframe how we look at that old hardware. That is not e-waste. Underneath that dusty plastic bezel is a hidden powerhouse, just waiting to be unlocked. It's honestly the absolute perfect, low-cost playground for running a bare metal hypervisor, self-hosting Docker containers, or even spinning up a Kubernetes cluster. Okay, let's dive right into this. Here is our blueprint for today. 1. The hardware foundation. 2. The missing parts checklist. 3. The always-on BIOS hack. And 4. Hardwiring your network.
Section 1. The hardware foundation. Unlocking the HP ProDesk 490 G2 MT. Before we actually start building, we need to validate what we have under the hood. The real secret sauce of this specific Haswell-era desktop is VTX, which is Intel's virtualization technology. See, these HP boards use the LGA 1150 socket, housing 4th-generation Intel processors like the Core i5 or i7 Haswell chips. And why does that matter to us? Because those chips natively support VTX right at the hardware level. It means a single power-efficient processor can basically slice itself up to run multiple isolated virtual machines or lightweight containers simultaneously without even breaking a sweat. It makes this older hardware incredibly capable for running environments like Proxmox, Talos Linux, or a whole fleet of Docker services, 24/7. Let's quickly break down the physical specs of this board to establish our foundation. Beyond that virtualization-ready CPU socket, the ProDesk motherboard gives us 4 memory slots, which is plenty of room for expansion. Plus, looking at the chassis, HP actually designed this case with some really useful specific bays. There's a large 3.5-inch cage for your heavy data drives and a smaller 2.5-inch internal bay. It's a surprisingly well-laid-out setup for a machine that was originally just meant to, run spreadsheets.
Section 2. The missing parts checklist. 3 crucial components for revival.
To transform this bare-bones tower into a working cluster node, we have 3 specific checklist steps. We need to install DDR3 RAM, insert a fresh CR2032 battery, and mount a SATA SSD boot drive. Let's tackle the memory first. 1600. That right there is your magic number for memory speed. This particular HP motherboard natively supports up to 32 gigabytes of DDR3 RAM running at 1600 megahertz. For a headless Linux server or a Proxmox node, 16 to 32 gigs of memory is a massive amount of headroom. It allows you to run dozens of services simultaneously. But, and this is a big but, you have to be super careful about exactly how you populate those 4 slots. Now, what's really interesting about this is how easily you can accidentally paralyze the system if you're just grabbing random memory from your spare parts bin. Let's say you have a mix, maybe 2 Crucial 4 gigabyte sticks, a Kingston 4 gigabyte stick, and an older Kingston 2 gigabyte stick. If you plug all of those in, your system might just sit there with a black screen. Why? Because that older 2 gigabyte stick might require 1.5 volts, while your Haswell CPU demands lower voltage 1.35 volt DDR3L memory. When the motherboard's memory controller tries to compromise between the different voltages and speeds, it essentially just gives up. You'll either get a loud 3-beep hardware error or it'll instantly hardlock. So you absolutely must stick to matching pairs. And always make sure to place them in the correct color-coded slots to activate dual-channel mode. Think of it like opening a 2-lane data highway for your processor instead of forcing it down a single-lane dirt road. Next on the checklist is the motherboard's memory. Well, actually, scratch that. I don't mean the RAM. I'm talking about the tiny 50-cent CR2032 coin cell battery. It is literally the cheapest part of the entire build. But if it's dead, which, let's be real, in a 10-year-old Office PC it almost certainly is, it's going to cause your biggest headaches. There is no way you want a 50-cent battery ruining an entire weekend of server configuration. Because without a fresh battery, the motherboard's CMOS will forget your boot order, your virtualization settings, and the system clock every single time you unplug it. Swap that out before you do anything else. Our final checklist item is storage. Whatever you do, do not try to run your modern server OS off the sluggish, ancient mechanical hard drive that originally came with the PC. Skip it entirely. Instead, grab a cheap 2.5-inch SATA SSD and slide it directly into that smaller metal bracket inside the chassis.
hook up your SATA data cable, and make absolutely sure you plug the other end into the dark blue port on the motherboard labeled SATA 0. Using SATA 0 guarantees the SSD gets the absolute highest boot priority, which means maximum server responsiveness the second you hit the power button. Section 3, the always-on BIOS hack. Server resilience.
Okay, so your hardware is physically assembled, but a home server isn't really a server if it stays offline after a power outage. See, corporate PCs are originally programmed to stay off after a power cut for safety reasons, but for a home lab server, that's a total disaster. So, the crucial point is this simple hack. Connect a keyboard, turn the machine on, and just repeatedly tap F10 to enter the HP BIOS. You're going to navigate over to the Advanced tab, find the BIOS Power On menu, and change the After Power Loss setting to On. This incredibly simple tweak ensures that if a thunderstorm knocks out the power to your house, the absolute second the electricity comes back, your server will automatically boot itself back up. It'll launch your containers, get everything running, all without you ever having to physically go press the power button. It's an absolute game changer.
Section 4, hardwiring your network. Stable connections only. Now that the server is built and it's booting up automatically, we have to get it reliably connected to your network. And I know you might be tempted to just slide a cheap PCI Wi-Fi card into this machine or use a little USB dongle. Don't do it. Servers demand a constant, always-on connection. Wi-Fi is inherently prone to latency spikes and minor signal drops. If you're running Kubernetes or any clustering software, a single random Wi-Fi latency spike can totally disrupt your cluster heartbeats, causing your entire infrastructure to think a node just died. Using the built-in Ethernet RJ45 jack on the back of the motherboard isn't just a suggestion. Hardwired Ethernet is the absolute professional choice for stability, throughput, and completely headache-free headless installations. And just like that, the whole shebang is complete. We've taken a piece of discarded office equipment, upgraded its memory architecture, made sure the motherboard actually remembers its settings, optimized the boot storage, hacked the BIOS for maximum uptime, and hardwired it for rock-solid stability. You now have a highly capable, virtualization-ready home server sitting right in front of you. The infrastructure is entirely yours, so the only real question left to answer is, what will you host first? Thank you so much for joining me for this explainer. I hope you found it as fascinating to learn about as I did to share it with you. Until next time, happy building!